Okay, full power applied, RPM is maxed out, engine pulling strong, the aircraft is sliding, bouncing over snowdrifts as speed builds. Watch the airspeed increase, the red angle of attack needle is high, showing high lift we need for liftoff, and there it is, rotation. We're airborne. Airspeed keeps increasing, and you can see the angle of attack now coming down below 60 as we're climbing out. The vertical airspeed in the top gauge, the altimeter, is showing that we're actually at 600 feet per minute. So we're at a good winter climb, dense air. And you'll see that the red angle of attack needle is flirting with about 60, so you know we're climbing. So once again, on the bottom left there is the airspeed indicator, white needle for airspeed, red for angle of attack. On the top left is our altimeter with the built-in vertical airspeed indicator, and on the far left, an RPM meter. Today we're testing the SteamGauge instrument system, a lightweight, reliable ecosystem designed for light aircraft. We've got a multifunctional airspeed indicator, precision altimeter with vertical airspeed, all connected through a high-accuracy pitot system. The pitot tube itself has got a 5-port on the front and a static port, and it's connected to the rest of the instruments using CAN bus. The design of the instruments are very lightweight. They're lighter than standard aircraft instruments, and of course more functionality than a standard aircraft instrument. Of course, as usually the case, the angle of attack indicator somewhat correlates to airspeed. So as the airspeed drops, you'll typically notice the angle of attack indicator increasing. It's not always the case. We'll see a little later that's not the case. The other thing that we'll see is that the angle of attack will often correlate with the vertical airspeed. So if we're climbing, we tend to see a higher angle of attack. Today we're gonna roughly do a circuit. We're climbing up to the circuit altitude of 1,000 feet AGL, which is 2,500 feet above sea level. And yeah, we're gonna, try and stall it a little bit and the nose down attitude and see how the angle of attack indicator and the airspeed and altimeters react. So now drop in the RPMs a little bit, and we're descending ever so slightly. Starting to turn onto the crosswind. This video is filmed with the Insta360 camera on a selfie pole off the wing. Nice panoramic view, and can actually see in this field where the aircraft is going, the land it's going to be passing over. Now, as you can see, we've pretty much leveled off, and in the low angle of attack. Throttle's pretty high, airspeed is high. Now we're going up. We're going to pull a little bit, get right up there, kind of stall it out. You can see the airspeed is now down, angle of attack is way up. pull a little bit more, so we are getting more vertical airspeed and we're stalling more. Right on the precipice here. And on the stick I can feel it bobbling. This aircraft doesn't stall like aggressively, it kind of mushes in to well behave from that perspective. Now kind of a nose down attitude, and you can see the angle of attack drop. And we are high, a few 100 feet higher than the circuit altitude. Now I'm descending. We're gonna get ready for an approach here. So I like to come in, use the ultralight circuit height, which is 500 feet now in Canada. So while I'm on the downwind here, I'll continue to descend. And as you can see in the descent, the angle of attack is right down. Airspeed is pretty high. It's about as high as it gets in this aircraft, about 60 miles per hour. And now we're really descending. And again, 2,000 feet is 500 feet AGL here. And again, thermals. It was a thermally day, first thermally day in a very long time. It was a long winter of, rather still air. The angle of side slip, which is displayed in the bottom left indicator, is not connected up currently. But normally that would be kind of like a yaw string indicator. And here we go, we're turning on to final. And at this point we want to try and keep the angle of attack at about 60. That's the idea. And that's what I'm doing. Boom, we just hit a thermal. And there's a lot of thermals right here. You can see it in the video. The plane is bumping around. And that's an interesting thing. As the you hit a thermal, the angle of attack indicator increases. And so all I'm doing is watching that red needle, trying to keep it horizontal at 60. And you can see the runway on the left-hand side of the image. Holding that 60, a little smoother now. And we're gonna flare. And you'll see the angle of attack increase until we touch down. And that's it. SteamGauge is built to provide light aircraft with clear, reliable flight data. We'd love to get your feedback. Drop your thoughts in the comments. Your input helps shape the next generation of SteamGauge instruments. Thanks for flying with us today, and see you on the next test.